this video, we're going to talk a little bit about the zeros of a polynomial function. All right, we're just going to kind of introduce the types of roots that you might find, or the types of zeros you might find, and then a way to list all the possible rational zeros. All right, so in this first example right here, I have the factored form of a polynomial function. So just looking at these three different types of factors here, all right, we see that we have zeros coming from this term. We have an x equals a negative 3. From this term right here, we have an x equals a negative square root of 2. And from this one, making sure that we go through and take the opposite of both of those, we have x equals a 4 minus a 5i. All right, now that should be review from your Algebra 2 class, where you set each one of those equal to 0 and then solve to get those zeros. All right, now from there, we can identify the type that they are. So x equals negative 3, that is a rational zero. The x equals negative square root of 2 is an irrational zero, because square root of 2 goes on forever and ever and ever. All right, and then this last one right here is what's called a complex imaginary zero, because we can see that we've got that complex number sitting there, 4 minus 5i. All right, so there's the type of zeros that we have. All right, now we can further classify these two as real zeros, and then we can call this one a non-real zero. All right, so you should be able to take your polynomial functions and then classify them, especially if they're in factored form, real easily there, find what those zeros are, and then be able to classify them in the various ways that we know how to do that. Okay, now over here we're going to use the rational root theorem, and basically that says that you're going to list all of your factors of your p number, which is the negative 2. You're going to list all of your factors of the q number, which is the coefficient there on that term, and then you're going to put p over q, and that's going to come up with all your possible rational zeros. All right, so we'll remember that this is our p and this is our q. All right, usually for the work on this, I write p over q, because that's your formula for finding those possible zeros, okay? Now, what we're going to do, all the factors of negative 2 are plus or minus 1 and plus or minus 2. So the factors of 2 were not too hard to find there. Now, on the bottom for our q, we're going to look at that coefficient of 15. We're going to list all the possible factors of 15. So we'll have plus or minus 1, we'll have plus or minus 3, plus or minus 5, and plus or minus 15. Now, once you have all of those listed, you are just going to need to put everything in the numerator over everything in the denominator. I would recommend doing it in a systematic pattern, such as plus or minus 1 over plus or minus 1. It's just going to give you plus or minus 1. Then I would do plus or minus 2 over the plus or minus 1. All right, and do that with each one of your sets. So, for us to then stay organized, plus or minus 1 over plus or minus 1 is just going to give us a plus or minus 1. The plus or minus 2 over plus or minus 1, again, is just going to give us a plus or minus 2. All right, now we're going to go plus or minus 1 over the plus or minus 3, so plus or minus 1 over 3. Okay, then we're going to take the other one in the numerator, put it over the 3, so plus or minus 2 over plus or minus 3, plus or minus 2/3. Then we're going to do the plus or minus 1 over the plus or minus 5. That'll give us a plus or minus 1 over 5. Then we're going to do the 2 over the 5. So plus or minus the 2 over the 5. Then we will do the 1 over 15, plus or minus 1 over 15. Then we'll do the 2 over 15, plus or minus 2 over 15. You just want to definitely do it in a systematic way, systematic pattern, so that you don't miss any of them. So right there is all of the possible rational zeros for that polynomial curve. So in this video, we wanted to keep it really short. We wanted to be able to identify the different types of zeros and then use that rational root theorem to list all of the possible rational zeros. Definitely thanks for watching. If the videos are helping, please be sure and share with your friends. And don't forget to give me a subscribe and a like. Thanks.